Hello, welcome to the last topic in our discussion about clarity and efficiency of code. If you have been observant, you realize that at the start of the slides, the agenda wrote clarity versus efficiency. And that actually may highlight the common misconception that when we want to have clarity, that means very clearly written code, we might have to trade off efficiency. It may not be attaining 100% that we could have attained. In general, there is a little bit of trade off, but the answer in general also is no. We should aim for both. The reality is that we might not achieve 100% efficiency that we could have when we sacrifice clarity, but reality is that if we achieve 99%, we sort of trade off 1%, we would get back immense amount of clarity in our program. And that is something we should think as a good thing. All right, so this is why we want a section to talk about this. We want both. We strive for both clarity and efficiency. Now, what is clarity? This is one big program, one big file. All my entire app program logic is here. There is no use of function or little bit, very sparing, no use of module, no blocks whatsoever, basically just one large file programming. So very hard to debug, probably duplicated, triplicated logic everywhere. When we need to change anything at all, and things always change, when we need to upgrade, maintain, revise, we cannot. Or we manage to change certain parts but forgot to update other parts, and therefore in the long run, it will result in incompatibilities, out of sync updates, and front part is working, rear end is not working as well, and so on. So lots of problems that we kind of begin to build into our code if we don't practice clarity of code. Now, clarity, there are two parts to it that I like to highlight. One is clarity of the logic, that the line of execution is clean, it's easy to understand, it's clear where certain faults must lie. Right? The guessing game is kept to the minimum. We are always in the know. We are like the commander of all troops organized into battalions and platoons, and we are very clear when certain problems occur. We know which module, which file, which part of that file has problem. The other part of clarity that we insist on is about the ability to be readable, to be understandable by human. So your program serves two purposes. Obviously, it has to be understood by machine. Python interpreter is going to understand your program code. The other reader, the other consumer of your program is human, yourself, your future self. Next time when you look at your code, next time when you want to borrow your code that you have developed in class or you have done together with your friends in a project and you are very proud of it, next time when you are working in a project that you kind of felt that last time you have written something familiar, you want to, copy and modify a little bit, you don't understand your own code, and that is the problem. So it needs to be readable by human about the intentions of this particular function, the intention of this particular line statement, the intention of this particular module. We talked about this earlier on, and when you do this, you get clarity. So use plenty of comments, document strings, doc strings, and practice using descriptive names for variable names, for class names, and for function names, and for module names, right? So use clear and descriptive words. Don't always use variable name ABC, function name XYZ, module name PQR. That would be, you would need another text file, documentation file to tell us P means what, Q means what. Now, unless you're trying to hide what you want to write, don't do this, right? So be clear, be expressive. Now, so practice these two, use modular programming, use lots of segmentation into separate files, each file serving big, higher level goals. Inside the file, you have related functions together. testing of each of these functions also in the same file because they test those functions, not other functions, and so on and so forth. Right? So in general, be clear, be organized, be modular. So this is something just to remind and to insist and to also inform you that this is the right thing to do. The other part of what we want to discuss is more interesting. It's the efficiency part. It's the chasing of getting the last nanosecond if possible, right? We want it to be fast. We want it to be efficient. Must we trade them off? Answer is no, right? Definitely, we want fast programs because then our user thinks our app is really responsive, really quick. They all switch over to use our app. Now, well, imagine the difference between WhatsApp, Telegram, Signal, right? Sending messages to your friends versus sending messages through the usual telcos SMS. If you're lucky, SMS messages get delivered a second later, 2 seconds later, but they never promise. Sometimes it can be 10 minutes later, sometimes it's an hour later. I don't know. It has been experienced before. When you use fast delivery apps, WhatsApp, Telegram, Signal, you get the idea that, wow, this is what I want, right? So same thing goes for our program. People like to get fast, highly efficient codes, so we definitely need that. But we don't sacrifice clarity at the same time. How do we do both, right? How do we do both? So I don't want to just keep saying that you have to do it, have to do it. I want to give you 2 pointers. Number one, try to use or try to aim for fast algorithms. At the macro level, we know that, for example, to find the shortest route from point A to point B, we should use certain algorithms, Dijkstra's algorithm, whatnot. Especially when your point nodes get larger and larger, it's already known that in computer science studies, in discrete mathematics, that this algorithm works the fastest, right? So if you know that, then use that algorithm. If you can implement it, implement it. If you cannot, then try to see if there are already existing packages, because that goes to our second uh, pointer, second advice, and that is to say, if at all possible, use already written, pre-tested, pre-optimized package module codes wherever possible. Number one, they give you clear function names, tends to be. Number two, they have been tested and it's stable and it's fast and it's meant for that purpose to implement that particular algorithm. So if that's the case, certainly strive to use that, right? So when these two are combined, we will actually be able to both obtain efficiency at the macro level because this is a fast algorithm, and at the same time keep the clarity of the program, the readability of the program, the reusability of the program intact. Okay, so let's not talk about complicated algorithms, but just adding numbers, adding